At 1:21 in the morning, a Boeing 777 carrying 239 people disappeared from civilian radar. There was no distress call, but it did not crash there. Military radar recorded it turning around, crossing Malaysia, and continuing toward the open ocean. Then it vanished again. Almost 6 hours later, a satellite received one final signal. Searchers have since scanned more than 200,000 square kilometers of seabed. Pieces of the aircraft have washed ashore, but the main wreckage has never been found. Now, a new search will return. The reward is $70 million, but only if the aircraft is discovered. How can a plane leave radar, satellite signals, and physical debris, yet remain missing 12 years later? To answer, we have to reconstruct the final 7 hours of MH370. On the night of March 7th, 2014, Malaysia Airlines Flight 370 waited at Kuala Lumpur International Airport. It was a Boeing 777-200ER, one of the most widely used long-range passenger aircraft in the world. Its registration was 9M-MRO. Its destination was Beijing. 12 crew members and 227 passengers were on board. At 12:42 in the morning, local time, the aircraft lifted from the runway and climbed northeast over the South China Sea. For the next half hour, nothing about the flight appeared unusual. The pilots communicated normally with air traffic control. The aircraft reached its cruising altitude. Its identifying signal appeared on controllers' screens, showing its call sign, position, and altitude as it followed the planned route toward Vietnam. At 1:19, Malaysian Air Traffic Control instructed the flight to contact controllers in Ho Chi Minh City. The final recorded reply from the cockpit was calm. "Good night, Malaysian 370. Investigators later examined the recording. They found no evidence of anxiety or stress in the voice. At 1:20, the aircraft passed a navigational point called IGARI, close to the boundary between Malaysian and Vietnamese-controlled airspace. It was a brief gap in responsibility. Kuala Lumpur had told the aircraft to change frequency, but Ho Chi Minh had not yet established contact. At 1:21 and 13 seconds, the identifying symbol for MH370 disappeared from civilian radar. No distress call was transmitted. No emergency code appeared, and the aircraft never contacted Ho Chi Minh City. To the civilian controllers watching that night, the flight had effectively vanished, but it was still in the air. Civilian air traffic control normally tracks an aircraft using a transponder. The device aboard the plane responds to radar interrogations and broadcasts identifying information. Primary radar works differently. It sends out energy and listens for a reflection from a physical object. The return is less informative, but the aircraft does not need to cooperate. Malaysia's military radar was still recording one of those returns. Just after MH370's identifying signal disappeared, the radar target turned away from its route to Beijing. It first moved back toward Malaysia, then it crossed the northern part of the peninsula, passed south of Penang Island, and continued northwest over the Strait of Malacca. This was not a small navigational correction. The aircraft had reversed direction, crossed back over the country from which it had departed, and moved toward the Andaman Sea. Investigators later recreated the initial turn in a Boeing 777 simulator. Their conclusion was limited but important. The turnback was likely made under manual control, not by the autopilot. They could not determine how the later turns were made, and they could not establish who, if anyone, was at the controls. At 2:22 in the morning, the military radar recorded the aircraft for the final time near a waypoint called Mekar. By then, it had been missing from civilian screens for about an hour. During the flight across Malaysia, the military target was classified as friendly. It was not considered a threat, and no interception was ordered. The people monitoring the country's airspace did not yet understand that the anonymous return was the center of an international emergency. The first disappearance had been an illusion created by the loss of one signal. The second was real. After 2/22, no radar station is known to have tracked MH370 again. The confusion began almost immediately. When MH370 failed to contact Ho Chi Minh City, Vietnamese controllers asked Kuala Lumpur for information. Calls moved between control centers and Malaysia Airlines. At different points, people working the problem were given inaccurate or unverified positions for the aircraft. For hours, there was no coordinated picture of what had happened. The flight had disappeared near an international airspace boundary. Its transponder was gone. The military radar track had not yet been integrated into the civilian response, and some of the systems used by the airline did not provide reliable real-time tracking. Kuala Lumpur's Aeronautical Rescue Coordination Center was activated at 5:30 in the morning, more than 4 hours after the aircraft disappeared from civilian radar. The formal distress message followed at 6:32, another hour and 2 minutes later. The official investigation documented failures in procedure, staffing, training, and coordination. Those failures do not explain why the aircraft turned around, and they do not prove that an earlier response would have changed the outcome. But they meant that while people on the ground were trying to decide where the aircraft had gone, MH370 may still have been flying farther away. By sunrise, it could have been thousands of kilometers from the place where the first search would begin, and there was one system still watching it. Not a radar station, a communication satellite. MH370 carried a satellite communication terminal. Even when it was not transmitting a phone call or a message, the system could exchange brief, automated signals with a ground station through an Inmarsat satellite. These exchanges became known as handshakes. They did not contain the aircraft's GPS coordinates. No message said that MH370 was at a particular latitude and longitude. Instead, investigators had to extract location from the behavior of the signal itself. The time taken for the signal to travel helped estimate the aircraft's distance from the satellite. But a distance does not produce one point on a map. It produces an enormous curved line of possible positions, an arc. The frequency of the signal also shifted as the aircraft, satellite, and ground station moved relative to one another. By comparing those changes with models of possible flights, investigators could test whether the aircraft had traveled north or south. The northern routes did not fit the evidence. The southern routes did. The signals indicated that MH370 had continued away from land, deep into the southern Indian Ocean. There were 7 important satellite arcs. The last exchange occurred at approximately 8:19 in the morning, Malaysian time, almost 7 hours after the transponder disappeared. And the final signal was different. It appeared to be a log-on request, the satellite terminal reconnecting after losing electrical power. One explanation was fuel exhaustion. If the engine stopped as the fuel ran out, electrical power would be interrupted. The auxiliary power unit could then attempt to start, briefly restoring power and causing the satellite equipment to log on again. The official investigation concluded that the engines likely operated for more than 7 hours, and that the aircraft probably flew until its fuel was exhausted. But even the final arc was not a crash site. It was still a line stretching across a vast ocean. Searchers now had a destination measured not in coordinates but in probabilities. The first aircraft and ships searched the South China Sea, close to the last civilian radar position. When the military track became clear, attention moved west toward the Strait of Malacca and the Andaman Sea. Then the satellite analysis moved the search again, this time thousands of kilometers south. The new region was among the most isolated places on Earth. The nearest ports were days away. Storms and large waves limited operations. In places, the seabed lay several kilometers below the surface and was cut by ridges, slopes, and deep terrain. Before search vehicles could look for wreckage, ships had to map sections of the ocean floor well enough to operate safely. Sonar vehicles then moved back and forth close to the seabed, examining narrow strips for shapes that might not be much larger than the natural geology around them. It was less like searching a room and more like mowing an invisible field in darkness, while the field itself was larger than many countries. Australia led an underwater search covering more than 120,000 square kilometers. It continued until January 2017. Ocean Infinity searched another large area in 2018. Together, the major underwater searches examined more than 200,000 square kilometers. They found shipwrecks. They mapped previously unknown underwater features. They investigated sonar contacts that appeared promising, but they did not find MH370. That failure did not prove the satellite analysis was wrong. Each estimate depended on assumptions: the aircraft's speed and altitude, its direction at different times, the winds it encountered, and what happened after the final satellite exchange. A small change near the beginning of the reconstruction could move the final location many kilometers across the seabed. Then, more than a year after the disappearance, the ocean returned part of the aircraft. In July 2015, a piece of an aircraft wing washed onto Reunion Island in the western Indian Ocean. It was a flaperon, a control surface from the trailing edge of the wing. Investigators confirmed that it came from 9M-MRO. For the first time, the disappearance had produced physical evidence from the aircraft itself. Other pieces were later recovered around the western Indian Ocean and along the African coast. Some were confirmed as belonging to MH370. Others were assessed as almost certain or highly likely to have come from it. Their locations were compatible with debris drifting west from the southern Indian Ocean over many months. But drift modeling works backwards through changing currents, winds, and time. It can strengthen or weaken a search region. It cannot reverse the ocean into a precise flight recorder. The condition of the debris offered another clue. Examination indicated that the right outboard flap was most likely retracted, and the flaperon close to neutral. That is not how a Boeing 777 would normally be configured for a deliberate landing on water. Cabin material also suggested that the aircraft had broken apart, but the pieces could not establish whether breakup began in the air or occurred when the aircraft struck the ocean. MH370 was no longer an aircraft that had vanished without leaving anything behind. It had left radar positions, satellite measurements, and fragments of its structure, yet none of those contained the one thing investigators needed most: a complete record of what happened inside the aircraft. The official investigation reached conclusions that were both significant and deeply incomplete. The aircraft's change of direction was likely caused by manual inputs. Investigators did not identify a plausible aircraft or system failure that could explain the combination of lost communications, the diversion, and the later route. But without the wreckage, they could not definitively eliminate a malfunction. They could not establish whether anyone other than the pilots flew the aircraft, and they could not exclude third-party intervention. That leaves several broad possibilities. A deliberate human diversion fits the initial manual turn and the coherent route across Malaysia. It could also explain why different communication systems ceased operating. But the evidence does not identify the person responsible, establish a motive, or reveal what happened in the cabin. A fire, depressurization, or cascading electrical failure might explain some lost communications. If everyone aboard became incapacitated, the aircraft could have continued under autopilot until it ran out of fuel. But no specific failure sequence has been found that explains the communication changes, the manual turn back, and the complete route together. a hijacking or other third-party intervention remains possible, but there is no verified claim of responsibility and no surviving evidence that identifies an intruder. One of the most controversial pieces of the investigation came from the captain's home flight simulator. Police recovered more than 2,700 coordinate fragments. Most were default game coordinates. 7 manually programmed waypoints, when connected, formed a path from Kuala Lumpur through the Andaman Sea toward the southern Indian Ocean. But forensic investigators could not determine whether those points came from one simulation or several. They found no route identical to MH370 and no matching climb, attitude, or heading maneuvers. The police report concluded that there was no unusual activity beyond game-related flight simulations. The simulator data is therefore evidence that must be described with its limitations. It is not proof of a planned disappearance. Every major theory can explain part of the story. None can explain all of it without adding events that the surviving evidence does not record. That is why the wreckage matters. Damage patterns could reveal the violence and angle of impact. Components might preserve evidence of fire, explosion, or mechanical failure. The flight data recorder could show control inputs and system states. The cockpit voice recorder, depending on what it retained and survived, might explain what happened in the final period of flight. Until those objects are recovered, every proposed solution reaches the same boundary: the ocean floor. In March 2025, Malaysia signed a new agreement with Ocean Infinity to examine a new 15,000 square kilometer area. The terms were simple in principle: no find, no fee. The search operated briefly in March 2025, then again from the end of December into January 2026. Across 28 operational days, 7,571 square kilometers were surveyed. No wreckage was found. Approximately 7,429 square kilometers remained. In June 2026, Malaysia extended the agreement through June 2027. Search assets are expected to return during the calmer weather period between November 2026 and April 2027. If the aircraft is found under the contract's conditions, Malaysia will pay $70 million. The size of the reward reflects what is still missing. Not merely a machine, but the final known location of 239 people, and the evidence their families have waited more than 12 years to see recovered. Finding the wreckage may show how MH370 reached the ocean. It may reveal whether the final descent was controlled or uncontrolled, whether a failure occurred, and what systems were operating in the last minutes. It may finally transform a probability arc into a place. But even finding the aircraft may not answer every question. The recorders may be damaged. Some decisions may never have been spoken aloud. A physical cause may not explain a human motive. For now, MH370 remains somewhere between what can be calculated and what can be known. It is not a story without evidence. It is a story in which every surviving piece of evidence stops just short of the answer.